Hello everyone, this is the Deathbed channel. If you are visiting the channel for the first time, nice to meet you. I'm an associate professor at a university in Japan. First, let me explain the purpose of this channel. The contents covered here are mainly related to mathematical physics. I aim to create an educational environment that is not constrained by time and location using the internet. However, there are many limitations to what can be done on the internet. I'd like to explore ways to clear those limitations as much as possible by utilizing tools that I have developed and computer simulations. While I'm not very good at speaking, I want to complement it with the tools I have developed. Additionally, I'm not sure how helpful the contents I can provide in this channel will be for people around the world. Therefore, by showing the video contents to global viewers, I hope to understand how useful it can be. I also want to treat slightly challenging contents for myself. Therefore, there might be some wrong discussions, so I would appreciate it if you could point them out through comments. Now, let's create a window and display a web application. Okay, please take a look at this window. This red line represents a virtual string with material properties like a steel. Please assume it as representing just a part of an acoustic guitar string. When we push the button and drag the pointer, we can pick up the string. After that, let's release the button. When I pluck this string, it vibrates like this image, as you can see. The motion is obtained by numerically solving the equation of motion for the string. Typically, visible and acoustic phenomena are more easily understood, so I plan to use examples like this one. You can see the elapsed time left below. Let's stop around here. Let's listen to the sound. Sound is synthesized from the vibration shown here. Can you hear a sound like plucking a string? We can freely adjust these parameters. By changing these parameters, the sound also changes. For example, let's shorten the length of the string. Push the button and drag this pointer and release the button. The step. Sound becomes higher like this one. Next, let's change a material property. I try to change the shear modulus lower. When we make the shear modulus lower, the duration of vibration becomes longer. So let's wait a bit. The whiteboard I'm using here will be made public, so you can also experience it. Since this is an introduction, I want to explain the details of the physics behind what's happening here. In other videos, I'll explain the physics and the mathematics necessary for simulating string vibrations. In this way, I hope that viewers can learn with experiencing the virtual physical phenomena. Okay, now let's make a sound. It became a bit strange sound, didn't it? Feel free to play around with various parameters. If you find any bugs, please let me know. I'd like to share some plans, so let me return the value. While focusing only on strings resulting in short duration sounds, I believe that we can extend the sound by creating structures that reflect sound. Then we will be able to synthesize sounds like an acoustic guitar. Moreover, while currently we can only blocking strings, when we simulate actions like striking the strings, we might be able to produce sounds similar to a piano. Further, by simulating striking a surface instead of a string, we could potentially replicate percussion string instruments. To realize these aspects, we not only need to consider equations of motion but also the wave equation. Of course, discussions involving mathematics and numerical solutions of differential equations will be necessary. Furthermore, to visually represent structures, the help of three-dimensional computer graphics is essential. I believe that this whiteboard makes it possible. Let me show you a simple example. Let's create a new window. Here, I'll display a web application using three-dimensional computer graphics. This is just a cube with shade and shadow. But I hope to represent various structures in the future. The videos, including various derivative discussions, will be uploaded. But if it is hard for you to understand everything, I encourage you to focus on the parts that interest you the most. This video is now concluded. Thank you for your watching and listening. See you next video.